So, good morning, everyone, or good afternoon, or good evening, wherever you are in the great big Zoom Facebook world. This is Seth Itzkan with my colleague Karl Thidemann of Soil4Climate. And we are thrilled today to welcome Nikita Zimov, who is the manager of the Pleistocene Park project in Russian Siberia. And they're trying to restore the mammoth steppe ecosystem, bringing in grazers to basically restore the grasslands and to help keep the thermal profile of the area on the cooler side and frozen, and to help prevent, frankly, a climate catastrophe. And it's a fascinating project. And if you just Google Pleistocene Park, you'll find tons of information about it. It's a wonderful article in the Atlantic and on their website. There's great videos. They're on Vimeo where it's hosting it. So even if you just go to Vimeo and type Pleistocene Park, but it perfectly is in line with the themes of Soil4Climate, because Soil4Climate. So we're about soil restoration to for the purpose of climate change mitigation and even global warming reversal. And it's interesting because our work has traditionally been in sort of the more dryland areas. And you see the picture behind me in the virtual screen here of the land in Zimbabwe on Alan Savory's property that's been restored with holistic planned grazing. And the situation up in Siberia is that the carbon is already, deep in the soil. It's the carbon bomb, as Mr. Zimov, refers to it, or the potential carbon bomb. So they're trying to keep it from being lost. But as he just explained to me a few minutes ago, nonetheless, a lot has already been lost, and they're trying to restore that with the grazing. So it's interesting, two completely different parts of the world, and yet it's sort of a similar story, if you will, the story of the megafauna being decimated by humans, and then the landscape transitioning to one which doesn't have the thermal profile necessary to help prevent global warming. And in both cases, animals are part of the solution. So that itself is sort of fascinating. Okay, so what we're going to do is Nikita will give his presentation, and then we'll take questions afterwards, and we have plenty of time. So let's just get started, okay? So Nikita, again, it's a pleasure, honor to have you, and the floor is yours.
Yeah, good morning, good day, everybody. Thanks for the invitation. And I think I will just start with the presentation itself. So I think it will be around 40-45 minutes long, and I think I will be happy to answer questions if you have any after my talk. So just to have some background on what's from the territory I'm coming from. So I run the Northeast Scientific Station, which is a research station located above the Arctic Circle in the Kalama River lowland. And the station was originally found back in 1980 by my father, Sergei Zimov. And the research station is operating ever since. And back at 1990, when the Soviet Union collapsed, the station became a private research station. So there was no more governmental funding for it. And since that time, the station actually grew quite substantially. It's now one of the largest Arctic research stations in the world. And we are operating year-round. And people come to do research from every different disciplines in the earth science. And we can host up to 40-50 people at the same time. And people from all over the world are visiting our research sites every year. Well, except for the last 2 years, for the kind of well-known reasons. So, and here's just some slides of our landscape. So, this different territory. 40, 42, 68, 97. Yeah, that's better. So the good thing about our project is that we.
Yeah, I just.
Good thing about our project that we are located in our territory, that there is a forest zones, tundra zones, forested floodplains, so all types of landscape you can reach within just one day. And we have different laboratories and some activities. And that's a last slide about our research. It's like a joke that, you know, even to do science, Russians are using tanks. So, however, the biggest project which was ever held on our research station is called Pleistocene Park. The idea of the project came to my father's head back in the 1980s. And since that time, the project have substantially developed both in terms of science and in terms of just practical development. So we'll have to do some background explanation about what's about. So back just 15,000 years ago, the world's largest ecosystem was called the Mammoth Steppe. So the ecosystem was spanning from modern day France to Canada and from Arctic islands to China. And very little known about this ecosystem now, or it was little known just recently, because when the Pleistocene era ended, this ecosystem relatively quickly vanished and left no present day's analogs. And for quite a long time, people were mostly, scientists were thinking that the ecosystem was similar to a polar desert. And that was done mostly on the intuitive level. It's people think, okay, Arctic is very cold right now, there is very little growing, there is no animals, and in the ice age it must have been even colder, so probably it was a desert, polar desert with very few animals. However, intuition is not always the best tool, especially there is some direct ways to measure or study how the ecosystem was functioning. So here in this slide, you see this dark orange territory. So the park is, I don't know if you see my mouse, but the park is located in this area. And this is called Thidemann territory. It's in this place, the soils of this Mammoth Steppe ecosystem persisted in the permafrost. And this is a one-year exposure, 120 kilometers up the river. And so the image is taken. So the sediments were slowly accumulating in the late Pleistocene. It was dust blowing, and sediments were accumulating on the surface with the average rate of about 1 millimeter per year. So in this manner, let's say over the 40,000 years, you could get about 40 meters of soil accumulated. And what's this sediments? So imagine that you have permafrost spanning for hundreds of meters below, but underneath there, not underneath there, but on the surface, every summer about half meter to a meter of soil is getting thawed. So that's basically the soil, the northern soil, which is thawing every summer and where all the activities, microbial and plant, is taking place. And if you cover the surface with 1 millimeter of sediments, on average, the bottom of the active layer, 1 millimeter, will not thaw next year. So this is, let's say, these sediments are the very bottom of the soil profile. So there is, let's say, 40,000 horizons of the very bottom of the soil profile. And these sediments allow, here it's the 1 year exposure, it's a Koloma river, it's a big Arctic river, which is eroding these sediments, and here they become visible and accessible. And there you can do some research, and here is some points which are very easy to detect. First of all, these sediments store a lot of organic carbon. So you see all those tiny little roots here on the screen. So those roots are about, let's say, 30,000 years ago, and there is even some peat. And overall, just in this relatively small area of 1 million square kilometers, there is more carbon than in all above ground vegetation of the planet. So it's a huge storage of carbon. Moreover, the carbon is very labile, and the sediments are very fertile. You would be surprised to know that this beautiful picture is taken at the open cast gold mine. Gold miners excavated those sediments to get to this gravel with gold, and they abandoned the mine, and already next year, the site is getting overgrown by those very productive grasses. About half of the sediments were already processed over the last 10,000 years by so-called migrating thermokarst lakes. So these sediments, apart from lots of carbon, they also contain lots of ice. And in case of a forest fire or something, the depth of the active layer increase, so the soil is so deeper in the summer, and the ice starting to melt, water escape, and in this place depressions appear, and depressions get filled with water, and little ponds are forming. And those ponds are starting to increase because water is causing additional warming effect. And our territory, there is millions and millions of thermokarst lakes. And they slowly grow and eroding the sediments. And the problem that underneath the lake, these sediments with lots of organic carbon is the carbon is stored, and microbes in an anaerobic condition convert those sediments into methane. And thermokarst lakes are noticeable member in the global methane budget. And here, you know, when the ice is forming on the lakes in the autumn, the methane is getting trapped underneath the ice, and such a fun entertainment is possible. I don't know if it will broadcast sound, but so you see, when people say that those are dangerous greenhouse gases, that's what they mean. So yes, first thing to remember that permafrost is a big storage of carbon, and it is vulnerable to the climate change, and it's quite important to keep it locked. Apart from carbon, these sediments, so the sediments also contain remains of animals which lived in this ecosystem in the past. And the bones are so abundant that you actually can restore the density of animals which lived in this ecosystem in the past. And that's what we did. So this is again this 1 year exposure. So all the sediments there are loess, so it's let's say loamy soils, and pretty much when it's melted, it all turned to mud. And in the Pleistocene there was no forest, so there was no big wood, there was no rocks. And when the river is eroding, all the mud is getting washed away, and the only solid particles which you can find in the permafrost, it's remains of big animals. And so when the river is eroding, all the mud is getting washed away, and all the bones are getting projected on the beach. And if you walk along this beach, you find bones of animals in big abundance. And if you talk about abundance, so that's the number of animals which we found walking for only 3 kilometers along the shore, and we found almost 1,000 different types of bones. And so they locate here. It's the wrong. Well, anyway, so we'll start talking. In this presentation, there is some slides missing, unfortunately. I missed that. Well, we'll explain by words. So the first thing which we detected that bones of smaller animals like reindeer, horses, and bison are usually we found them randomly on the shore. But with mammoths, the situation was different. We could walk along the shore for maybe 100 meters and not see even a single mammoth bone. And then we walk and we run into one mammoth bone, and we look around and we see a few other bones of mammoths. Maybe let's say 10-15 meter radius. Then we walk another 50 meters without seeing any bones, and we find another accumulation of mammoth bones, maybe 5, 6, 12. And in this manner, we found 29 accumulations over the 3 kilometers without any single case where we found just one with no bones around it. And from that, we concluded that all those, well, also we saw that in every accumulation, the quality of bones, the size of bones indicated that those bones could belong to one animal. And since we found 29 accumulations, it was very clear for us that we actually found 29 different dead mammoths. And after that, we actually used a relatively simple math. We know the area which we scanned, the area of the shore. We know how much time it took those sediments to accumulate because there was lots of carbon dating in this site. And we know the average lifetime expectancy of mammoths. And knowing all that, we found that on average, over the, let's say, 30,000 year period, What the hell? I think there is something drawing on the screen, no?
I don't know where that was coming from. Wasn't my end. Let's just continue.
Yeah, I think we are getting hacked, which is funny. I'm actually even flattered.
Me too. Me too. Yeah. I'm flattered.
Yeah. Well, anyway, so on average, for 30,000 years, on every kilometer, they roamed one mammoth. Yeah, I don't know what's going on and who is doing that. Seth, do you know how to find out? I think is it not coming from my computer, I guess.
Okay, sorry, we figured out who it was and we've fixed it. All okay, right. You can continue. The culprit has been dealt with.
Let me stop the demonstration and start it again. All right, funny. Up. All right, so on every square kilometer, they roamed one mammoth over the 30,000 years period on average. And that means that in Siberia, it wasn't a polar desert, there was at least thousands, millions and millions of mammoths roaming in this landscape. So that was a very big ecosystem, at least, well, only just counting skeletons directly, we measured that. Secondly, the question, well, okay, it was called the mammoth steppe, but were mammoths actually the dominant animals in this ecosystem or not? And we managed to restore that too. So we found very good dependency between size of the bone and its probability to preserve. Let's look at this picture. So here with the bison skeleton, we tried to put the bones where they should belong in the skeleton. And we found many bones of legs, because bone legs are rather sturdy, rather thick, and they are poorly disintegrating in the permafrost. So, well, nothing is disintegrating in the permafrost, but before you get to the permafrost, it takes usually, I know, centuries or sometimes thousands of years. So the bones should preserve well. But at the same time, ribs of this animal, of bison, we found only a few, not enough even for one skeleton, maybe let's say a quarter of skeleton. And because those bones are very thin, and we found very good relationship between, let's say, the size of the bone and its probability to preserve. And we managed to get connections between different bones. So let's say big bone of horse is like medium sized bone of bison. And we know that they should be preserving well. And if one is more abundant than the other one, that means that horses are by a certain ratio more abundant than bison. And finding those connections, because we know that we found that bison are 5 times more abundant than mammoths, horses were 8 times more abundant than mammoths, and reindeers were 15 times more abundant than mammoths. And after that, we managed to understand that on every square kilometer of northern pastures in Pleistocene, there was roaming around 10 tons of biomass of big herbivores, which is extremely a lot. And I think outside of national parks in Africa, there is no wild ecosystems on the planet right now where you can have higher density of animals. In some domestic landscapes, farms, the density may be higher, but that's very rare examples. So, and the ecosystem was huge. So we were measuring this number of animals in one of the most northern and driest landscapes. So that's this ecosystem was extremely productive. And the sad story, well, let's say, if you put this number into context, if you would climb up the hill on a sunny day, you would see that there would be thousands of animals roaming around you. You would be looking around for, let's say, several kilometers, and you would see thousands of animals. Now I have a house, well, I have a hill not very far from my house, and I visit it a few times a year, and I climb it up, and I have never seen even a single herbivore in my life there. And that's a, you know, that's a sad difference. So, and the question, for many people, it's very striking. We are talking about the high Arctic and it's very cold, and how can it be even possible to have so much forage, so many animals, and how can you get enough forage for those animals, which is the main question. And the answer is actually not that hard to answer. The question is not that hard to answer. If you have well, what is productivity? Productivity depends on two things. It's kind of just what's called gross productivity. So how much photosynthesis you have versus how much respiration you have. You need to grow everything quickly and you need to decay everything quickly. And in the modern Arctic, productivity, so the photosynthesis is relatively active. We have lots of sun. So let's say from June to late August, early September, there is lots of sun and the temperatures are positive. And for photosynthesis, you do not need high temperatures. It's a photochemical reaction. And, for example, in June, July, we have photosynthesis going for 20 hours plus. But at the same time, if something has grown, it will stay in the ecosystem for a very long time without decomposition. So our climate in the Arctic, unlike what you have in Africa, is very cold, very dry, and even grass, when it dies, stays as litter for several years without allowing new grass to grow. If you have a dead tree, it can stay upright for even a century, for almost a century. So that's a totally different story. And with animals, if you have animals in this ecosystem, the total productivity is much higher because photosynthesis is happening very active, but at the same time, decomposition of above ground vegetation is happening in the stomachs of animals within, let's say, 24 hours. In the modern tundra, average turnover of nitrogen is more than a century. So it takes more than 100 years for one molecule of nitrogen to pass through this nature cycle. And in the ecosystem where you have grazers, it takes probably a year. Sometimes it might be even less than a year. So the grass starts to grow in the beginning of the summer. Someone come, eat it, digest, and take nutrients back to the soil. And later in the season, the grass picks up these nutrients again. And in a sense, it is possible, it is theoretically possible to have 10-ton biomass in the Arctic, or 10-ton biomass of big herbivores in the Arctic. Okay, if this ecosystem was so powerful, then why did it disappear? And there was, let's say, there is two main theories behind that. First one is that it was because of the climate. So in the Pleistocene, it was dark. Well, in the Pleistocene, it was cold and dry, and the modern climate became wet and warm, and the animals which used to live in the cold climate couldn't resist that. That's the first theory. And the second is theory of, let's say, overkill. We are pretty much opposed to the theory of climate for several reasons. First of all, let me see if yes, I have the slides. As I said, Mammoth steppe ecosystem was the largest world largest ecosystem. Mammoths lived in Spain and in New Siberian Islands. And the climate in those two locations is extremely, extremely different. And it was different before that. So this ecosystem could sustain in very wide variety of climates. Plus, this ecosystem sustained numerous glacial interglacial cycles, which were in the last, hundreds thousands of years. So several glacial interglacial cycles, which occurred in the last million years, and it went fine. And moreover, there was done many numerous radiocarbon dating of remains of animals which were found, and they were found remains of animals like horses, mammoth, bison, which lived in the north long before the climate, after the climate have changed. So if horse can live in the modern climate for 1,000 years, it means that it can live normally up to nowadays, but they didn't. And we more of a saw, we at the time when we were preparing this publication, we took all known radiocarbon dating of bones of animals which were done in the Beringia region and in the north, so all the remains of animals from the permafrost, and we saw that there was actually increase in number of animals after the climate became warmer and wetter. Well, it's it's quite logic, because if your animals are limited by productivity, by amount of forage, if your climate gets warmer and wetter, that means your productivity go up. If your productivity go up, you can sustain more animals, and the animals everywhere reacted positively. So here in this graph, the red line, so to the right it's Pleistocene, to the left it's a modern age, and you see that all the peaks are going up after the red line, and the sharp decline is happening several centuries after. And the only thing that corresponds well with that is the first appearance of humans in the Arctic. So back in the Pleistocene, there was no humans in the Arctic. So that landscape was extremely unfriendly to people. It was winter most of the year. It was flat landscape. There was no wood, no shelters. And if you would imagine in your head the Ice Age human, most of you would envision the huge guy with muscles and the big club in his hand. But in reality, the human society, the average person would be something like 10-year-old girl. So we are the slowest, we are the weakest, we are the most defenseless. And for us to survive anywhere, we need to have extremely safe way of life. And the Arctic did not provide safe way of life for people, for women, for kids. And when the climate changed, only after that, humans, first of all, their technology developed. And they will start a migration away from Europe, going through Asia, then to the north, then through Bering Strait, entering North America and going to South America. And I think this route took like 700 years. So it was relatively a vast expansion. And everywhere people were seeing the defenseless, not the defenseless, but animals which didn't know this new predator. And humans are not the most efficient members of the ecosystem. So we became the top predator without knowing how to be a top predator. And unfortunately, we even now don't know how to be efficient top predator. And that's causing us lots of troubles. And the further people went, the deadlier were the consequences. So that's a nice image of what species survives in Europe. In our place, there were reindeer, horses, bison, mammoths, woolly rhinoceros, lions, wolves, and only reindeers and wolves survived. In North America, out of many animals, only bison survived. And in South America, I think there was more than 50 species of animals with a body weight over 44 kilograms, and every single species went extinct. So the further people went, the deadlier were the consequences. And let's say, after people destroyed those modern, not modern, but natural, high productive grazing ecosystems, those ecosystems vanished. In the north, for example, you don't need to kill every single mammoth. In our case, grasses in the north cannot compete against mosses, shrubs, and trees without help of animals, because they can only rapidly grow, and their main, let's say, competitive advantage, they feed animals which are fighting against other vegetation for them. And if you remove, bison and mammoths and keep the number of animals low for extended period of time, animals will not be sufficient to consume all the grass. So the litter will accumulate on the landscape. The mosses, shrubs, and trees will start to grow. And few centuries later, if you keep number of animals low, grasses will disappear. And if your grasses disappear, then there is no way even the small number of animals can survive. For instance, if you're a mammoth, you need good pastures to survive through the winter. You cannot browse on the poor vegetation. You would die by the new year. That's like the sad reality. So let's say I would probably even speculate that last mammoths on the continent died not because of the spear, but because of starvation. So humans did not kill every animal. They destroyed the ecosystem, and outside of ecosystem, animals cannot live. And later, let's say a few centuries later, humans learned how to create their own grazing ecosystems. But the ecosystems which they're using are much less efficient. So wild ecosystems, they had a big variety of animals. Everything was very well consumed, and all our grazing ecosystems, it's usually only cow or only one type of crop, only one harvest a year. And for us to maintain our civilization, we use a lot of non-renewable resources, like coal, gas, fertilizers, which we mine. But according to our research, we saw what density of animals we had in the north and what densities could be in the other areas around the world where the high productive grazing ecosystems used to be. And we see that wild nature, solely on renewable resource of the sun, managed to maintain, let's say, biomass of the big herbivores of this, let's say, civilization of wild nature, 30% more than the biomass of our civilization. So biomass of our civilization, it's a weight of all humans, weight of all cows, chicken, pig, whatever, what else we have. And we maintain, so our 7 billion people, by trashing the planet, and we already have huge problems with that. And the wild nature managed to have more biomass maintained and very environmentally friendly. So it's kind of 2 points. First one is showing how inefficient we are. And that's a sad side of that. But at the same time, you know, it's showing that there is a lot to learn from the nature, how to manage the land efficiently, and how for us to survive as a humankind, as a civilization in the future. Because the way we are treating the planet right now, how many people we have on the planet, how we're using the land, it's not giving us, let's say, good hopes for the future. So, and the idea that, let's see, the idea of the Pleistocene Park is to kind of show, create, restore those wild ecosystems and try to learn from them how to manage land efficiently. At the same time, apart from restoring nature to how it was and having it efficient, this ecosystem allowed to give some profits in terms of the climate. So as you all know, the climate change is coming and we have to do something about it. And this ecosystem does have some things how it can help. So there is 4 phenomena which we usually well, now it's somehow in French. I'm sorry, I think I picked the slides last moment, and I think it was, I took the wrong file where it's, I think it was presentation for some French people. Anyway, you either can read French or just listen to me, I will try to explain. So first thing is albedo effect. The lighter the surface, the higher energy, a higher portion of energy is reflected back to space. And grasslands are lighter than forests and shrubs. So in the summer, it's a shades of green, still noticeable, but let's say effect not that great. But if we talk about spring, so in April and May, right now in the place where in the park, there is enormous amounts of sun. There is doesn't get dark already, and you cannot walk without sunglasses outside because it's so bright. And you see that all the pastures are still white and reflecting all the energy back to space. And shrubs and trees are pretty much shades of dark, of black and gray. And we measured, we put some solar radiation equipment in the park and outside of the park, and we saw that over this 1.5 month period, there is more than 100 to 200 watts per square meter additionally reflected from this landscape. So which is quite a big thing. So pastures allowed to have direct colder climate. So without kind of accounted for any greenhouse gases or anything, just a lighter surface, colder climate. Secondly, as we already discussed, permafrost is huge storage of carbon, and with climate change, the Arctic is getting warmer twice faster than the rest of the world. So in the territory of the park, the climate became warmer by 3 degrees in the last 30-35 years. And after the following the temperature of air, temperature of permafrost is also increasing. So when I was a kid, it used to be -6. Now it's -3 and warmer. And the trend is about 0.1 degree per year. And just to give you some understanding numbers. So temperature of air when I was a kid was -11. Temperature of permafrost was -6. Now it is -8 and -3. So there is this 5-degree gap between temperature of air and temperature of permafrost. And the reason why permafrost is warmer than air is because in the summer, sun energy is penetrating easily to the ground and warming up the surface. But in the winter, the ground cannot lose its heat easily because the snow is forming on the surface and the snow doesn't allow this energy to escape well. And if you would remove the snow entirely, you would cool the temperature of permafrost by 5 degrees. So temperature of air -8 would be, and temperature of permafrost would also be -8, which is great. However, how can you get rid of snow? You can either take, thousands and thousands of bulldozers and plow all the snow in the Arctic, but I really doubt positive climate effect after burning so much diesel fuel. At the same time, there is an environmentally friendly way. If you have animals, if you have pastures, and you have something juicy underneath the snow, the animals will come to this place and they will excavate the snow and trample it down, and that snow will lose its heat insulating abilities. And this will allow to have much colder permafrost. So I think realistically we can cool the permafrost by 2 to 3 degrees, which is quite a big deal. So I think it might give us decades to centuries, and some permafrost can even stay intact under some, let's say, more or less mild climate warming scenarios, if you'll be able to keep in this Paris Agreement ideal world. All right. And third, I think, after listening to me for half an hour, I am finally getting to this topic which you might like. It's about soils. I think many of you heard, and I don't know how you feel about it, but if you would start talking with the regular people around the world and say, how can we save the climate with the nature? I think pretty much everybody will say we need to plant trees. And that's the most common belief which people think. And there is many fundraising projects, and there is many activities going into planting trees. And I agree that in some cases that it really does make sense. However, I think in most of Russia and definitely in the Arctic, it doesn't. And the reason that if you're talking about tropics, in the tropics, the only way, well, first of all, trees in the tropics are big. If you plant a tree, it will grow fast and it will sequester a lot of carbon, and you can store a lot of carbon in the forms of stems of trees. But in the Arctic, the situation is totally different. Our trees are so tiny and they're taking so long to grow that you would spend centuries to accumulate a couple kilograms of carbon per square meter, which is not very lot. At the same time, for example, in the tropics, where it's warm and moist, in the soil, you cannot store much carbon. Well, as much as in the Arctic, let's say. I'm not going to offend anyone here. But if it's warm and it's moist, big storage of carbon in the soil will decompose. But in the Arctic, where it's cold, where it's relatively dry, and where soils are frozen for most of the year, even the small input of carbon into the ground will slowly but kind of progressively increase the carbon storage. So even in the modern poor soils under the, let's say, large trees, the most poor soils we have, store 10 to 16 kilograms of carbon per square meter, which is, let's say, 5 to 8 times more than the above ground vegetation stores. However, this vegetation, all the vegetation in the modern forest, so the large trees, they do not grow roots deep. All the roots are along the surface. All the mosses, lichens, and evergreen shrubs, they also either don't have any root system or don't have any deep root system. And all the carbon is located in the top, let's say, 10, 20 centimeters of soil. That's it. Underneath, there is a mineral layer. But if you establish grasses, herbs, and if you have grazing, it's a totally different story. The carbon is getting accumulated in the soil much more rapidly, we said, because grasses are growing, they are very productive, they need lots of water. If they need lots of water, they are looking for water. What they do, they grow deeper. The deeper they grow, the colder it is, the less likely this carbon will decompose. And what's I don't have any slides. All right, and in this sense, you can accumulate much more carbon in these forms of roots than by stems of trees. In the park, we already have about 26 kilograms of carbon per square meter on this kind of the most oldest fenced area which we have, which is 4 kilograms more per square meter than just outside of the park, where there is also similar landscape, but which was not affected by animals. Our estimates show that we can store about 100 to 500 grams of carbon, so of carbon, not CO2, 500 to 500 grams, with, let's say, average 300 grams per square meter per year. And the capacity of active flare in our territory is, I think, the maximum capacity is somewhere close to 100 kilograms per square meter. So at the moment, we, on most of the territory in the Arctic, have 10. But if we have animals, those animals will work for decades and centuries and slowly accumulating carbon in the soil. So if you can get 100 or even, I think, even more than 100 kilograms of carbon per square meter, that's a huge potential. The Arctic is big. There are millions of square kilometers. The land is not used. There is no cities, no farms, no activity, no roads. And right now it's occupied by the large forest, where nothing is growing but this large, which no one eats, and only mosquitoes like this place. Yeah, and the fourth phenomenon, we'll, I think, get back maybe to carbon later with questions. But the fourth thing, that if you have high productive ecosystem, you have high active photosynthesis. Active photosynthesis means a lot of evapotranspiration, means your vegetation dries out the soil, and you have much less wetlands and lakes. So our territory, even though we have arid climate, we have lots of wetlands. There is permafrost underneath, there is no drainage, and photosynthesis is very slow. Mosses does not allow water to evaporate. And all our landscape is water saturated, and there is a lot of methane production. If you have high productive grasses, soils are dry, and you don't have methane produced. And methane is much stronger greenhouse gas. And according to our estimates, animals, ruminants, if you have animals roaming in this place, they do produce methane, but that's about maybe 20 to 25% of the methane which would be otherwise produced by wetlands in this territory. So yes, animals do produce methane, but they still do it less than what wetlands in this landscape do otherwise. So, all right, so what we are doing, if in the past humans destroyed this high productive grazing ecosystems by reducing number of animals and keeping it low for extended period of time, we will do the opposite. We will artificially increase number of animals and keep it high for extended period of time to allow animals through grazing promote growth of grasses and have this cascade effects and establish for them this enough ecosystem where there would be enough forage for them, where we will be no longer needed to support the living. So at the moment, what we are doing, back in 90s, my dad received a relatively big piece of land from the Russian government, which is about 160 square kilometers. And first we fenced this territory. Well, not entirely. I think our fence is about 20 square kilometers. So it's about 20 kilometers perimeter, and it covering 20 square kilometers. Right now, this year, we are planning to substantially strengthen the fence, because sometimes we have problems with big animals which doesn't want to get keep inside. So we closed the perimeter and we started to bring animals in. And first we started with animals which we could find locally. So first animals was a moose, and I think the images, I would say, self-explanatory. So here the moose is crossing the mountain river and here the moose is already in the boat. So while they're small, they need quite a lot of attention from outside, but they grow quickly, and we just release them in the area, and we rarely see them because they're native to the landscape and they don't need our help. They browse on willow very well, and we have lots of willow shrub in the area. So that's that's a big one, the only friendly one which we had. Then there is another animals which we could find locally. It's Yakutian horses. It's a semi-wild breed of horses which is kept by native people for meat. And for them, you just need to drive around 800 kilometers on the winter road, and you get them in a big truck. And a couple of days later, they are in the Pleistocene Park. And we have already several generations of horses in the park. That was the first animals we could, I think my father brought in 90s, and we sometimes bring the new ones. And we have 3 or 4 herds right now roaming in the park, and they do quite well. Then the easiest animals to bring in are reindeers. So just 100 kilometers up north in Tundra, there are native reindeer herders, and you can relatively cheap buy the reindeers from them. And unfortunately, they never want to, but we put them on a barge and start going to the park. And a few hours later, they're released in the park, and you see they're doing very well on browsing on the shrubs. You can see from this image, and the grasses too. And unfortunately, as I said, our landscape is not very rich with wild nature, and you cannot find any other animals. And for all other animals, we have to do much more complicated expeditions. And here I will show some slides from our expedition in 2010 to the Wrangel Island. That was our cruise class, ocean class cruise ship, which we used. And the path there took us about 7 or 8 days, I think. And the reason was because it took so long that at some point we ran into lots of floating ice, and it took us 3 or 4 days to find the path through this floating ice to get to the island. And there was some wildlife we saw on the way. And finally, on the island, it took us about other 10 days to look for the muskox. So the animals which we introduced there in mid-70s, and catch them. And the muskox are animals which I think at some point they went almost extinct. They were small populations left only in Greenland and in the very north of Canada. And after that, humans start to take action to populate them in the Arctic. And I think now these animals are doing more or less good. And the reason why they became extinct, almost extinct, because they have a very poor defending strategy. If other animals, when they sense the danger, run away, these guys, they don't run away, they pile up in herd, and they looking with adults looking out with their horns, and the main male running around ready to attack with babies inside. And for example, against wolves, that's a great strategy. But if you're a person with a gun, you will kill an entire herd. And I think that was what used to happen in the past. So, however, that made it easier for us, the strategy, because if you put a circle of people around the herd, the guy with the tranquilizer and the gun shoots the baby, and the baby falls asleep. And then for 5 hours, we were waiting for baby to wake up. And it's a high Arctic. It was extremely cold, windy, and waiting for 5 hours, I was trying to keep myself warm by cuddling with the muskox. And that was our catch. Well, not all of them we took, but so we took 6 of them. So that's a cute one, and put them in the deck of in the cages, and put them in our deck of our small boat. And on the way back, there was no ice, but we for 2 days in a row we were in the very bad storm in the open ocean, and everybody was quite seasick, both the crew and the members and the passengers. However, fortunately, we made it safe to the park, and all the animals were released. And so that's them in the park the first weeks, and that's some of them several years later already. Then another kind of expedition I want to show what we're doing. 2 years ago already, we did expedition to bring some bison to the Pleistocene Park. That was our long hope to bring animals, bison to the park, because bison were the main species in the Pleistocene, and we made many attempts to bring bison, and many of them failed. And finally, in 2019, we found a good way to do that. So we found a lovely bison farm in Denmark, where they have around 400 bison, and they sold them to us for the dozen for a reasonable price. And through Europe, the animals were traveling in this fancy cow bus. And when they entered Russia, at the border of Russia, we met it with our not that fancy cow bus, which was pretty much handmade out of 40-feet container under, let's say, my design. And then we started going to the Pleistocene Park through entire Russia. And since the journey was long, we were feeding animals all the time and giving them water and cleaning after them to make sure they are safe. And unfortunately, Russia is not known for its good roads. And as you go east, the situation is getting progressively worse. So we had to, in some cases, take ferries to cross the rivers. And we were going through the dirt roads and the mountain ridges. And finally, we reached the small river port just 500 kilometers from Pacific Ocean along the upper flow of the Kalama. And that's where the road ends. And from there, we had to load our bison on the small barge. And last 1,500 kilometers, we were going on the barge with the animals and arrived early spring with, it's a flood. So Kalama River is getting flooded most of the territory, and we released the bison in the upland in the park, and that's some of them few days later. And I think that's our last slide. Just with updates. So for the plans, for this year, we are, let's say, 10 days from now, I think I'm starting another expedition where I will be bringing some goats, fur goats, 40 fur goats and 12 camel to the Pleistocene Park. And later this summer, I think we will be transporting European bisons, wisons, and Przhevalsky horses from France to Russia, and then going to Arkhangelsk, which is seaport in the Northern Sea, and then animals will go on the big ship through the Arctic Ocean directly to our local town, and from there we'll bring them to the park. So that's a more or less confirmed plans for this summer. And overall, the hope for us that what we want to do, we want to make self-sustainable, high productive grazing ecosystem. We want to make this ecosystem be independent from humans. So we want to have herbivores, we want to introduce predators as a key factor, and we want this ecosystem to grow and occupy new territories. We want to get, let's say, enough science and public support to show that what we are doing is really meaningful and is profitable for native people, for governments, for the climate, and for everybody, and for the nature. And we hope that when we are successful with the Pleistocene Park where it is now, we hope we will be able to establish parks in the other part of the world, in the Arctic, maybe not only in the Arctic, and eventually allow those ecosystems to grow and eventually merge. And I think that it's very ambitious goal, but I think it's kind of worth trying to do that, because I think that's kind of quite important for us. First of all, to mitigate climate change, and secondly, just to learn how to make our planet, let's say, the way it is, and I think it will help our civilization to sustain in the future. And by this, I think I'm done with the talk. Thank you very much, and I am ready to take your questions.
Well, thank you, Nikita. Let's get a huge round of applause, everyone. Let me see everybody clapping for Nikita. Thank you, really, you're a hero. We're not worthy. We really, I want to say on behalf of Soil4Climate, we absolutely stand with you, okay, shoulder to shoulder. There are so many themes that you hit on that we concur with completely. First of all, the term geotherapy. I don't know if you've heard that term, but it's an important term, geotherapy, not to be confused with geoengineering. Okay, geotherapy. And then, using biological systems, and then particularly the fact that you are using the grassland ecosystem and that you're using animals. That's the key point. We just love that. Using animals to mitigate global warming. It's like, pow, it's so counterintuitive to the narrative that's out there. So amen to you for that.
Yes, a couple hours ago, my wife was asking me, I said, well, tonight I'm giving a talk, and she's asking, who am I giving talk to? And said, well, I think there should be pretty much a lot of allies to our idea in that crowd.
Yeah, we're absolutely allies. So in the interest of time, let me just move quickly. First of all, I just started during this talk, I started a fundraiser for the Pleistocene Park project in the Soil4Climate Facebook area. And the idea of raising money to buy animals for ecological restoration is something we've been doing for a while. People who follow Soil4Climate know that we've been buying cows for our Maasai project in Kenya. So it would be totally appropriate for us to try and buy a reindeer for your project. So I have created a fundraiser for that. Obviously, people can just go to your website and donate directly. They don't need to go through us, but I would love it. I would be honored if people contributed through the Soil4Climate fundraiser so we could donate to your project on behalf of Soil4Climate. And now with that, let's just move on to the questions. I want to first call on Gustav Solberg, because it's because of him that I met you. So Gustav, the floor is yours if you want to ask the first question. And you'll have to unmute yourself, of course. Oh, and then people, if you haven't done Zoom before, if you want to ask a question, you raise your hand. You see at the bottom of your Zoom screen, it says reactions. And if you click on that, one of the options is to raise your hand. Then we'll call on you. Okay, I'm getting a message from Gustav saying he can't unmute himself. Hang on a second.
Yes. Also, I see there is some questions in the chat, so I can answer them afterwards.
Okay, Gustav, you should be able to unmute yourself now. Okay,
Hello?
go for it. Yep.
Can people hear me?
Yeah.
Okay. Yeah, it's that's quite a project you have going there. That's absolutely stunning seeing what you're doing. I love the big scale picture you have. That's so important in this day and age. We need to get stuff going. So I just want to get an idea of how many animals do you have in this enclosed area right now, and maybe you could also say again how big is the area.
Yes.
And I have another question as well after that, if you could answer that as well. What type of support do you see in this project? Is there a lot of critique from people to get the government on board, NGOs and those kind of people? Thank you.
Yeah, sure. So the first question, the area which we officially own is about 144 square kilometers, but I think if we would need, we could easily expand it a lot, because there is, let's say, with the borders which we have, it's no one's land outside of there, and the modern ecosystems in the Arctic, they do not give profits to people. So that's a kind of main situation. There is very few people living in the Arctic because those ecosystem does not give them enough profit. So there is no farms, no towns, and you cannot feed yourself off this land. There is very few herbivores, and as I said, the only creatures there in abundance are mosquitoes. So territory is relatively, what we have is relatively easy to expand. Second, we now I think have around 100 to 150 animals, so not that much. But say it's in our case, animals, it's not really members of the ecosystem yet. It's rather a tool. So we're using those animals to create this new ecosystem. So we are right now, most of those animals are living off our support in the winter, for example, because the modern state of pastures is not good enough for them to live in the winter, and we maintain them, and for that they're converting the landscape. Second, in terms of support, well, Russian, for example, if you talk about Russian government, it is, I think, not supporting us directly, but we, first of all, we have a land for free, and I think I don't really pay almost any taxes right now. So I don't pay any land taxes, and they really cut my taxes for any type of business activity. So here I'm quite happy about that. Overall, what we are doing, as you said, it's broadly many, let's say 10 years ago, I would say that, just two crazy Russian scientists doing some crazy things, and there would be very few allies. And now the number of people who support the idea is slowly growing, and the governments are very conservative. Any government is very conservative, and for them to start supporting you, they will not support you until you're at, like, say, majority. So our support is mostly coming, first of all, from the money which we make on the research station, and secondly through the public donations. And in the last few years, that's actually slowly but progressively increasing. And now I think in the last year, we actually raised more than we invested from our own expenses, which is extremely great. And I'm very happy that that's changing. So I think the level of, let's say, public support, it's more or less kind of reasonable in terms of how much let's say, how many supporters we have of the idea. So the more people we have to think that what we're doing is correct, and they follow the same, this what you said, geotherapy. So that's actually, I haven't heard the term, so I think I might be using that. There is also like nature-based solutions, and all those terms, I think they need to be kind of used for people to understand. So overall, let's say more support would be great, because at the moment we are just creating our small, let's say sort of a zoo, but we need to build ecosystems. And I understand that probably the governments are not yet ready. We are not at the kind of at the level where they would be easily supporting us, but we hope that in the future, at least public support would be increasing, because the more support we get, the more we get done.
Okay, Nikita, we are standing, like I said, shoulder to shoulder with you to get the public support there. Now, it's interesting that you just mentioned geotherapy, because the man who coined the term and wrote the book on geotherapy is going, well, okay, maybe he didn't coin the term, but the man who wrote the book on geotherapy is the next person to ask you a question, Dr. Thomas Goreau. We're honored to have you with us. Tom, you're next. Go for it.
Okay, could you hear me?
Yeah, we hear you.
Great. Okay. Well, thank you so much, all of you. I didn't write the book. I edited the book. And I've got to say that Seth took the photographs on the cover. They show some of the pictures that are behind him of the regeneration of ecosystems in Zimbabwe. And I think the point of this book is actually there's 600 pages of 30 different chapters, I think. And they pretty much show people who regenerated soil fertility, ecosystem productivity, and biodiversity in basically every continent of the world except Antarctica, and almost every ecosystem, except, I'm sorry to say, we didn't get a chapter from you and your father on the tundra, which we would have loved to have had, but I think it's mentioned. But the point is that it can be done in every ecosystem. It needs to be done in every ecosystem. And what you're showing, showing there with the increase of the grassland is fantastic. It's an incredible example. And I just hope that you're able to get sort of the scientific data that's needed to back your case that you're increasing the carbon storage in the system, the recycling, as you mentioned, accelerating the nutrient cycling. That's how you get a lot of productivity, is by accelerating that. And then also, the impacts on the water and heat balance. These are really important to document. And so I just, want to make sure that you say something about that. But let me just add one more thing, and that is that about nearly 70 years ago, my grandfather was involved. He photographed transplanting muskox between Canada and Alaska. And I have all those photographs, so he would have very much appreciated what you're doing. So it's really a pleasure to hear what you're doing. I also say one more thing is that through my grandfather, we worked with the caribou Inuit of the tundra of Canada, who were not herders, but they were hunters. And they're suffering the most incredible changes in their ecosystems caused by climate change. Because they were hunters and not herders, they're not doing what you're doing. But I think it would benefit them a great deal, because essentially their caribou are disappearing. So anyway, thank you for what you're doing. And please say something about how you're going to monitor the climate change and carbon impacts. So thank you.
Yes. Yes, about the science. So indeed, there is we need to do much more science than we do. We're trying to do some. The problem that science is very expensive and it's very time consuming. And I'm trying to attract different scientific groups to do the job for me. But I did not show, let's say, I took their own presentation, and we did quite intensive mapping of how much carbon we have in the area in the park. And let me maybe just show the screen just briefly. I found the right slide, and just briefly show a couple graphs. One sec. Wrong one. Sorry. Так, this one. Yeah, for example, this example, that's soil profiles. So the blue one, it's a typical modern ecosystem in the Arctic. So you can see that most of the carbon is by the surface, and it's sharply going down as you go deeper. So that's 1 meter depth. And outside of the park, where there's also high productive grasses and shrubs growing, but without any animals present, that's how the green one, that's how you have much more carbon in the soil, but still, let's say, it's going down with depth. And that's the red one, that's what we have in the park. So we have actually been increasing carbon content with depth after, let's say, 20 years of grazing in the same landscape. So we are doing this, some research on that. So what we are doing right now in the park, in June, we are starting the big eddy coverance tower, which will be measuring CO2, methane fluxes, energy balance in the park. And we used to have that. We might have another 2 towers, the same, but lower one. We are measuring this carbon content. We are trying to measure the temperature in the soil and in permafrost, and so measure albedo effect. So there is some activities which we do. And I would encourage, if you have any scientists who would want to come and do research, yes, you're very welcome. And I will be very happy to accommodate scientists doing that research. So, all right. Other questions?
Okay, yes. We have a question from Pablo Manzano. And then after that, Pablo, after you, Karl is going to read some questions which are in the chat window. Okay, Pablo, go for it.
Thank you. Spasiba, Nikita. I'm a big follower of the work of you and your father for a long time now, so I'm glad to meet you through this talk. I have 2 questions also related to the kind of ecology work that I do. One is regarding seed dispersal, because in some talks that I have seen from you folks in the internet, I've seen that you have some issues in recolonizing some areas through restricted seed dispersal. I wonder if you are doing research on that, and if how does it look? Because I myself have been researching that in more temperate areas, and there are specific times where seed availability is higher. So there's some degree of manipulation that you can do through herbivores through that. But there's another question, because I also follow the theories from William Bond that you may have heard of, and Franz Vera, both for savanna ecosystems and also for temperate Europe forest areas that are actually much more open than they seem. And I think it has a lot to do with the kind of work that you are doing, not so much regarding the tundra, but rather for the taiga ecosystem, and well, what you have illustrated about the lower carbon content in large forests, etc. So my question is, in other areas in the world, in other systems in the world, the ecology and the ecological functionality of these landscapes, once the mega herbivores have disappeared, has been maintained by local peoples through pastoralism, through fires, through targeted grazing, actually a little bit also the main theme of the Soil4Carbon group. So I'm wondering what is the issue in the circumarctic area where you are working, where this has not worked through reindeer or through the Kalmykian cattle or through the horses that you also have in the park? Is it that the density of people was not enough? Is it that the management was not enough to replicate the uses of the people did not replicate the ecology of the wild herbivores? I wonder also if the fire is also a tool to clear the forest. Because I know that the invading forest is an issue that you have. Spasiba.
About the seeds. So yes, we did notice that at some point that we have, for example, in the cut in the forest, when we build the fence and this bare ground, we get animals, we get some fertilizers there, but the grasses are not really growing. And we realized that there's just not enough seed pool. And that's actually a big problem, that seed pool is poor, and there is some grasses and herbs available in the Arctic, but they are not that abundant. And we are in the last, I think my understanding started to come maybe 3-4 years ago, when I started to try to invest into some research in where I can buy some seeds or borrow or harvest them. And the last summer, we spent some time walking some in the floodplains where the drained lakes or where there is permafrost exposure is getting overgrown, or the, let's say, landfills near the town where there is this fireweed is growing, and we were collecting seeds. At those time, trying to buy seeds in the mainland, trying to find Arctic adapted seeds, because you can find some seeds of grasses, but in big quantity. But sometimes they are not very good for the Arctic, so they are, let's say, from the temperate climate, and it's taking us some efforts. So I'm planting them in different places and see how well they do, and if any grasses are doing better than the others. So, but also here is some science and some professionals would be great, because let's say, honestly saying, my personal background is a math major. So I was brought to this ecology by my father, and sometimes I'm lacking knowledge, and let's say now I'm lacking time to get this knowledge. So I would be very happy if there would be any botany scientists who would come and do the investigation of what we have in the park and how to make the proper assemblage, because herbivores are not working without herbs. So that's why, and we are missing. If we want to create ecosystem, we need to look at every branch. And also I start having a feeling that we might have a problem with insects. So I am sure that we need to get some insects which process dung, like beetles which process dung, because we don't have that in the current ecosystem. And we maybe need to look for some science entomologists who would advise us if it's possible, even those insects are available. Because maybe, people are talking about mammoths which went extinct, but maybe there was a special beetle which went extinct, and without it, maybe it will be very hard to establish a self-sustainable grazing ecosystem, because it's we know our knowledge in how to create a full functioning ecosystem is very limited. Let's say we know that these ecosystems once existed, and we know that it was sustainable, and we know some parts of the puzzle. but some I think could be missing, and I don't know if we can find out how to restore it. So that's a kind of big challenge.
Thank you.
And regarding the question on forest that I did on why pastoralists were not able to contain the forest in the tundra ecosystem.
Yeah. With so we are not in the tundra ecosystem. Tundra is actually extremely small, narrow part, like pure tundra without any trees. It's a very narrow part along the Arctic Ocean. So most of the territories with boreal forest or forest tundra. So we are located in this forest tundra zone, and it's quite vast. In terms of maintaining the forest, I think no one's really bothered. You know, Arctic, very few people, and with ecosystem, no one is really bothering with management. With forest, I think may help. We have part of the park, small portion of the park, fenced the area which burned back in 1981. And that was a forest, and there is a lot of still many dead trees out there, but that's the place where animals really like the most. So they visit this old, 40-year-old fire more frequently than any other place. And so I think forest fires, it's will be very beneficial to establish grazing ecosystems, because, you know, if it's a very dense, large stand, animals will just not walk into this place. Maybe if we would have mammoths or elephants, they would just knock down the trees, but the smaller herbivores, unless there is something to eat, they will just not convert this place. So if you need to have something like little bites for them to have, if you don't have anything, then they might not walk into this landscape. In this sense, I'm actually hoping, so the goats which I'm bringing, the goats are known to eat pretty much everything. And I hope that they might be a good addition. I will not be able to release them just like straight, because I'm afraid local predators might eat them. But from terms of ecological impact, I think goats might be very, very good addition because of their that they kind of able to eat what other animals would never do. They would never eat. And also another note, unfortunately, forest fires are illegal. I am very sad that, let's say, I want to make a forest fire in the park, but I don't want to go to jail. And that's a complex problem which I'm thinking how to solve.
All right, thank you, Nikita. There was a comment, and I hope I'm pronouncing the name correctly, Deanne Cody. First, she says it's so close to, so close to Alaska. I hope that Alaskans are modeling your park. And she also asks, is it possible to visit the park?
So yes, park is possible to visit. Unfortunately, it's not that easy to go through Alaska. I don't think there is direct flights, even if we forget about COVID. There is not that much direct flights between Alaska and Siberia, if any. So most people who visit the park, they're going through Moscow, and that's quite a lot of flight hours. But yes, in general, it's our station and the park is open for visitors. And I think we have, in 2019, we had like more than 100 people visiting the station and the park. Very few tourists, so it's mostly scientists and media, but because it's very remote, but in general possible. And about Alaska, so I was showing you images of our expedition with a bison from Denmark, and it was in 2019. In 2018, we spent 6 months trying to get bison from Alaska to Chersky. And I had the same vision, like, you know, Alaska is so close. And we did a lot of efforts. We found the bison from some native herders. We put them on a quarantine. We got all the permissions and lots of paperwork. We did all the cages, and then we just couldn't find the air company which would would agree to fly from Alaska to Siberia with the bison. It was we spent 6 months. So for 6 months, the bison were on the quarantine, living like in the small fenced area, because we were trying to find the airplane and we couldn't. And some people said, yes, we will do that. And the last day they flaked, and that happened numerous times. And already in the autumn, I said, okay, let's see. We just drained enormous amounts of money with no success. We just need to stop. And that was a very big failure. of ours. And let's say, fortunately, next year we found how to do it without any airplanes. I really hate airplanes. They're so, let's say, if you have a truck, it's relying on you. If you have airplane, you're relying on the weather, on the owners, on the politics, and anything. So,
are there groups that you are aware of in Alaska or elsewhere attempting to sort of recreate what you and your father have done? Any similar projects?
Actually, in the Arctic, not really. It is very expensive. It is very complicated, and I think bureaucracy in Alaska and Canada is extremely severe. So it's not that easy.
Okay. D and other D ask, would it be too cost prohibitive to get animals from the Canadian Arctic?
Well, I already answered that. So
with
it's let's say, no, I think if you would be bringing them in big numbers, then it would be all right. So let's say our budget was around 100 to 150,000 bucks. And if we would have around $300,000, I think we would already be able to do it, because we would bring, let's say, 40 instead of 10. So it's a question of the scale. If you have big money, you can charter big airplanes and more serious air companies, and not like private airplanes in Alaska.
Yeah. Antonio asks, are there later phase plans to introduce predators?
Oh, yes, definitely. So it's, many people ask, and journalists really like to ask questions about mamas, like about cloning mamas, and everybody, it's a sexy topic. And they ask how critical it is to have mamas. And I usually say them that, mamas, it's imagine you would tomorrow lose your right arm. You would be, let's say, still be able to do everything that you do, just less efficiently, slower. So same with mamas. I think we will be able to create a high productive grazing ecosystem, and without mamas, it will just be less aggressive and probably less effective, but still function. But without predators, I'm sure that our project will fail. Predators shape the behavior of herbivores to make them graze efficiently. Without predators, herbivores will do overgrazing in one place, will not go to the other place, they will not trample snow. And I think predators are extremely important. It's like there is a plants, herbivores, and predators, and I think all three are equally important. And without, let's say, it's just the problem that I need to have at least, let's say, 1,000 animals more or less adapted to environment, and then I will be able to start introducing predators. And it's also, I cannot just bring a tiger from the forest. It should be my animals never saw a predator. I need to have a predator who never saw a prey, ideally. To have them, let's say, coexist and learn how to coexist with each other. It's a complex problem, but we need to solve it. Let's say, without predators, no way.
So there are no predators in the fenced area at this time?
There is some, like wolverine, there is some bears climbing in and back, but they're not really kind of touching my big herbivores. So it should be wolves. We do have wolves in the region, but those wolves also, for some reason, never came to the park. And also at this stage, when I have very few animals, I don't want wolves in the park. And also, it should be the Amur tiger, which is actually extremely endangered, and it was suffering and very close to extinction recently, and now it's even more there because of the swine flu. So all the tigers are located near the China border, and I think like 60% of the meal it's boars, and boars dropped in number 30 times because of the swine flu, and that's a great challenge for them. So let's see, bringing those tigers to the Pleistocene Park might be one of the few ways to get them not extinct in the wilderness. And also African lions, the animal which this cave lion which we had in the Pleistocene in our region apparently have 100% same genetics as African lion. So it was just, let's say, just a lion. It's called African, not because it's African. It's just because it's sustained only, kind of persisted till nowadays only in Africa.
Understood. Jess Rubin asks, and this information may already be on your website. She asks, can you please post a description and call to scientists to come do research there? I can share it broadly with my colleagues and the larger scientific community we work within.
Let's say I was thinking about it. I don't know how to make advertisement correctly. It's like usually, and also the scientific community and Arctic scientific community is very small, and it's usually like, I know the guy who knows the guy, and this guy connects me with the third guy, and so I just don't know how to make advertisement correctly. It's if you think you might know of a, let's say, professor who might know something about it, just let's kind of chat with him.
Sure. Perhaps Jess could contact you directly offline. And Jess would be happy to facilitate that connection if we can be of assistance. Our friend Henry Swayze in Vermont asks, what will it take to grow the number of animals needed to make a big impact on global warming? How can it happen fast enough to save the world?
Good question. Well, good thing that animals can grow, let's say 20-30% a year, which at this rate they can populate fast. So pretty much I think it's money, political will, and kind of social awareness. I think those three things which are needed for the rapid growth, the main thing. The rest, let's say, is it's about science, learn how to do it right and efficient. Then I think it's possible. Maybe, and also, it's now it's not a question of how can we entirely, I think I saw somewhere in the chat that we need to drain 1,000 gigaton from the atmosphere. That's probably not from the atmosphere, but sequester 1,000 gigaton. That's, I'm afraid, not even going to happen. And that's not a question how can we solve the problem. It's a question how can we make our life not that miserable. So any projection is bad. It's just a question of that we should try to go not on the worst one.
Yeah. Benoit Lambert, in the same comment that you were just referring to, has asked, I don't know if there's an estimate as to how many animals would be needed to withdraw a gigaton of CO2 or a ton of CO2.
Yeah, actually, I don't think that we need to take 1,000 gigaton out. Right now in the atmosphere, there is 700 gigaton CO2. As we will start taking the CO2 from the atmosphere, if imagine we can suck, it will start sucking it from the ocean, because the ocean was sequestering. Also, yeah, I think maybe 1,000 gigaton is the number which we emitted in the last century, 3 centuries, more or less correct, but we don't need to drain that much. 1 gigaton, let's say, if we have 300 grams per square meter, we need 3 million square kilometers to drain 1 gigaton a year. So if you withdraw 1 gigaton a year, we need 3 million square kilometers. And for that, we need, like, say, 30 animals per square kilometer. 30 animals by 3 million, 100 million animals, a lot.
I just want to clarify, the 1,000 gigatons he was referring to CO2, and for carbon, we need to remove about 300 gigatons of carbon. So.
Oh yeah, maybe. So yeah, in this case, 1 gigaton of CO2, then less. Then I think we need like 30 million animals, and they will be withdrawing that amount every year. So that's right now. I think if we take all the reindeers, there is, let's say, 1 million of reindeers, and the rest is just absent. And you need to start, bringing animals in big numbers. So if you start with, let's say, 10,000 bison, in 30 years there will be many millions bison if you allow them to reproduce non-stop. How much? It will take a lot of efforts and a lot of money, yes, but
yes, we need more animals all over the world. All right, I'll turn it back over to Seth. I know we're coming up on the on our end time. So again, thank you very much, Nikita. We all appreciate your time.
Yes, I think you can share my email throughout the team. So if someone have questions, they can mail me. I'm not promising I will answer them very quickly, But after reminder, I definitely will.
Nikita, hi, this is Seth again, and thank you so much for everything. I just want to make a statement and ask a question if you have time to answer it. But
Sure.
the statement is that you know, we stand with you. We're shoulder to shoulder in this effort of geotherapy. You know, using ecosystem services to mitigate, if not reverse, global warming. And yes, the technology part of it is essential to replace the energy sector. You know, in case we all agree on that, we need different technology to make differences in terms of energy, manufacturing, transportation. We get it. But in terms of actually drawing the excess carbon out of the atmosphere and in mitigating the release of more, you know, this is the role of humans working with biology. And it turns out that animals are an essential ally in this. And an amen to what you're doing. Now, so we want you to know that we're absolutely your brother in this effort. And our focus is, like I said at the start, has been more in the sort of the dry land areas, but it's the same type of theme. And sort of my last question is just, what's your vision? What's your optimistic vision for how this scales significantly? I mean, you know, whatever you're doing now in your closed in area, whatever you prove, you know, the reality is this has got to get very big, very quick. It's got to be all over. And so what's your vision, your optimistic scenario for how this expands quickly, and what role can we play in helping to make that happen?
I think, well, kind of the more people are aware, the kind of educational part is extremely important. Like without that, there will be no growth, there will be no people supporting it, and no money coming in. So we need money coming in. We need people to understand that unless money will come into these ideas, this kind of geotherapy ideas, then kind of just you know, going to electric car will not solve the problem. It may slow down the, let's say, the rate at which the problem will go worse, but it will never get better. That's for sure. In terms of kind of personal optimistic, I don't know. It's a complicated problem. It's, you know, if you will start thinking about that a lot, you may think, oh, you know, it's too late. It's kind of, we are still doomed, and you can lack your motivation to kind of progress everything, go in this, well, trying to solve the problem. So in my just personal philosophy, I'm trying to do as much as possible. Kind of, yeah, I know that's a rat path. It's a very long path, but the only way to go through it is to start walking. It's a, you know, there is I have a nice, you know, little fairy tale to explain my kind of vision about that, and that might be a good ending point for the talk. So there is a big jar of milk was standing in the kitchen, and 3 mice fell into that, or trying to get, and it's have a glass, and they can't get out, and all 3 of them are swimming there, and the first one is like, oh, well, you know, we are doomed, kind of, there is nothing can be done, and it just dives and never to dive out. The second one is like, oh, the milk, finally, there's so much milk, and they start drinking the milk, and it drinks, and it also drowns. And the third one, it's like, you know, there is no point in trying to escape, but it's just trying to escape, like jumping, and 3 hours later, it creates a butter out of milk and get out of this butter. So I'm hoping that I'm, you know, I'm this third miles. It's extremely hard task, but, you know, I'm trying my best to kind of accomplish. And there is last year, it's actually extremely crazy in terms of amounts of expeditions which I planned, and all the other activities which we're doing, and I'm a bit even overwhelmed. But let's say, doing that, I understand that we are moving in the right direction. Are we moving fast enough? I don't know. We need to accelerate in the future for sure. But let's say, if I'm not moving right now, then we will not accelerate in the future.
Okay, well, Nikita, that's a wonderful fairy tale to end with the mouse going like this and making butter. That's perfect. Thank you so much. Consider us one of those mice, and you're one of the mice. to you and to everyone else, this is being recorded automatically. And then when it's done, it will generate a link and I'll share the link. Okay.
Yes, thank you very much.
Yeah. Okay. Thank you so much. We'll be in touch some more. Okay. Okay. Bye, Nikita. Bye, everyone. And you know what? If you don't mind, I like to do a little ritual where I ask people to unmute themselves and everyone just say bye. And so we just have this loud cacophony, little chaos of everyone saying bye. So go ahead, friends, unmute yourselves for a gallery view.
Bye-bye.
Everyone just say
Bye.
Say
Bye.
Thank you for all
Bye.
you do.
God bless.
Bye. Thank you.
Make it
Godspeed.
happen.
Onwards and upwards.
There's a
All right,
future.
bye.
Okay, everyone. Thanks so much. All right. Bye-bye.
Back to picture of Dan.